a very straightforward derivative of variance, right? So I'm building up a list of our measures of dispersion here. So we already talked about variance. We calculated variance using this formula here. A very straightforward derivative of variance is standard deviation. So we denote it with just the sigma symbol, which is convenient because its units are now on the same scale as the values in our distribution. And we get variance to that same scale as the values in our distribution by taking the square root of variance. So the place where variance gets out of whack relative to our data points is this point here where we square them. So to restore this measure back down to the same scale, we simply take the square root of variance, and that leaves us with the standard deviation. So in the preceding video, we calculated sigma squared, the variance, for our distribution x, and in order to convert that into a standard deviation, we simply use this really straightforward formula. We take the square root of the variance, and that gives us the standard deviation. So we just take the square root of our sigma squared, and that gives us the standard deviation. And yeah, so this shows us, by hand, manually, quote unquote, we are using a computer, but in a number of steps, I'm showing you how we get variance, sigma squared, and how that relates to a standard deviation. But there is a NumPy built-in method to make your life very easy. So you can simply pass x into this standard deviation method, and it pops out for you the same value as we got doing it our more manual way. And because now the standard deviation is on the same scale as our data points that are in our vector x, we can plot them on a plot. So here is a histogram of our distribution x, and this orange bar, vertical bar, corresponds to the mean of our distribution. And so that's also x bar. We calculated x bar in the preceding video. And a common thing to do is to show the standard deviation of our distribution by having a plus or minus relative to the mean. So this vertical green line corresponds to the mean plus the standard deviation, and this one corresponds to the mean minus the standard deviation. Nice, so now we've covered variance and standard deviation. The only measure of dispersion left, the only major measure of dispersion left, is standard error. That's next.